Good morning children, welcome to digital lessons. In the last session, we have studied Debonnier's law of traits, Newland's law of octaves, Mendeleev's periodic table. In today's session, we will learn about modern periodic table. Now, classification of elements, the periodic table. It is the modern periodic table. Now, he is the person behind the modern periodic table. Who is he? Yes, he is Henry J. Moseley, shortly called as H. J. Moseley. He is a British chemist. By analyzing the X-ray patterns, Moseley was able to calculate the number of positive charges in the atoms of respective elements. The number of positive charges called protons in the atom of an element he called the atomic number. With the analysis, Moseley realized that atomic number is the fundamental characteristic of an element rather than atomic weight. Now, children, in the last session we have studied about Mendeleev periodic table. There we studied that atomic weights are important in his classification, but according to Moseley, atomic number is the basis. Why? Because due to X-ray diffraction studies, he studied that number of protons and electrons are involved in the chemical reaction. Therefore, instead of keeping atomic weights, he used the term atomic number, that is nothing but number of protons and number of electrons. Later on, he realized that the electrons were the basis for the chemical reactions in all elements. Now, based on X-ray diffraction studies, Moseley estimated that atomic number is the basis for the periodic table when compared to Mendeleev's atomic weights. Now, according to him, atomic number is nothing but number of protons and electrons. Moseley used the number of electrons which are involved in the chemical reactions, and he arranged the periodic table according to atomic numbers. Now, the periodic law is changed from atomic weight concept to atomic number concept. Now, it is called modern periodic law. What is modern periodic law? Now, the physical and chemical properties of the elements are the periodic functions of their atomic numbers. It is the modern periodic law. Discuss the concept of atomic numbers and how to write atomic numbers with the help of your teacher. Already you learnt in the lesson atomic structure. With reference to the modern periodic law, the elements are arranged in the increasing order of atomic numbers in the modern periodic table. Let us see. Now, children, look at the periodic table. How the atomic numbers are arranged in the periodic table in the increasing order: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Like this, all numbers are arranged in the increasing order up to 103 here and up to 118 here. In periodic table, now there are 118 elements. All elements are arranged in the form of increasing order of atomic numbers along the period. Now, modern periodic table is also called as Moseley's classical periodic table or the long form of the periodic table. There are two names for modern periodic table. Atomic number of an element indicates not only the positive charges, that is the protons in the nucleus of the atom of the element, but also the number of electrons in the neutral atom of that element. Dear children, we learnt already that atomic number is nothing but not only the number of protons inside the atom, but also the number of electrons in the neutral gaseous atom. The physical and chemical properties of atoms of the elements depend not on the number of protons, but on the number of electrons and their arrangements, that is called electronic configuration in atoms. Children, we have already discussed that the atomic number is the main reason behind this modern periodic table. Now, children, we already discussed that atomic number is the basis for modern periodic table. Atomic number is nothing but number of protons, but in this periodic table he used the term electrons instead of protons, because they took part in the reaction very actively. Therefore, the modern periodic law may be stated as the physical and chemical properties of elements or the periodic functions of the electronic configuration of their atoms. It depends on electronic configuration of the elements. Modern periodic table has 18 vertical columns like this and 7 horizontal rows called periods like this. It is one period starting from potassium, calcium, scandium and ending with krypton, and it is the group starting with beryllium, magnesium, calcium, strontium, barium and radium. In the periodic table there are 18 vertical columns, they are called as groups. There are 7 horizontal rows, they are called as periods. Now, groups, the vertical columns in the periodic table starting from top to bottom are called groups. There are 18 groups in the periodic table. There are 2 groups of beryllium group and boron family. Now, the elements with similar outer shell electronic configuration in their atoms are the same column are called group. In group, one fundamental property we can observe. If we compare the electronic configuration, the outermost electronic configuration of all elements will be same within the group. Now, here you observe in beryllium, it belongs to which group, children? It belongs to second group. Here 4s2, 1s2, next 2s2, 3s2, 4s2, like this it will be go on adding in this group. Now, it is boron group, it belongs to which group? 5th A group. Here also outermost electronic configuration of the elements will be similar. Now, they are represented by using Roman numerals from 1 to 8 with the letters A and B in the traditional notations. According to latest recommendation of the UPAC, UPAC means International Union of Pure and Applied Chemistry. These groups are represented by Arabic numerals. They are 1 to 18 with no A and B designations. Now, in India we are combining them and using the notations like this. You see here. Now, we use the latest system with the traditional heading following in the parentheses. Now, you see example group 2, it is written as 2A in Roman numerals. Both notations we are following in India. Group 16, it is written as 6th A group. Now, in the modern periodic table, group of elements are also called as element family or chemical families. Elements in each family have similar but not identical properties. For example, lithium, sodium, potassium and other members of the family 1A are all soft, white and shiny metals. Here the metals like sodium and potassium, even we cut them with knife, they are very soft. All elements in a family have the same number of valence electrons. Now, if we go for valency of electrons, only one valence electron we can find in the outermost orbit. Now, lithium 2s1 outermost electronic configuration, sodium. Now, in lithium we will have the electronic configuration 2s1 and in sodium we will have in the outermost configuration like that same one electron we will find while we go down the group. What is the valency of this group? 1, because one electron is present in the outermost orbit of this group. Therefore, it belongs to the family called alkali metals or group 1A elements. For example, group 1A has lithium to francium with outermost electronic configuration NS1, and it is called alkali metal family. Now, group 2 atoms have 2 electrons in the outer shells. You see, beryllium is having total 4 electrons in the first shell, 2 electrons, outermost shell 2 electrons. Next, magnesium, you see, in the outer shell you see there are only 2 electrons. All these groups, second means all elements in the group beryllium, magnesium, calcium, strontium, barium, radium, all will have 2 electrons in the outermost orbit. Therefore, they belong to group 2. Which elements are present in first group? Now, look here children, what are the elements present in the first group? Lithium, sodium, potassium, rubidium, cesium and francium. Now, where is the first group? It is also called 1A group. Here it is. Now, what are the elements? You can see from hydrogen to francium. What is these are called alkali metals. What is the electronic configuration of these group elements? NS1. NS1, N nothing but its principal quantum number. We can say its electrons in the outermost orbit. Alkali metals, they are the most reactive metals. They are react very violent with water. Alkali metals are never found as free elements in nature. They are always bounded with another elements. We cannot see free elements as it is in the nature. Now, why hydrogen does not belong to alkali metals? You discuss with your teacher, because hydrogen is a not metal, it is a gas, and it is also having the property of the halogen group. Therefore, it is not appropriate to discuss, even though it is kept under alkali metals, it is not a alkali metal. Which elements are present in the second group? Now, the elements present in second group are beryllium, magnesium, calcium, strontium, barium and radium. It is second A group. Now, these are called alkaline earth metals. Electronic configuration of this group is NS2. There are 2 electrons in the outermost orbit. Which elements are present in third group? Boron, aluminum, gallium, indium, tellurium. Now, where it is? It is here. It is also called third A group. The elements from top to bottom. What is its electronic configuration? NP1. It is called boron family. Why? Because it is starting with boron and ending with tellurium. Electronic configuration is NP1. In p orbital we are having 1 electron. Before this we will be having NS2 orbital. Therefore, there will be 3 electrons in the outermost orbit of this group. Which elements are present in fourth group? In fourth group we are having the elements like carbon, silicon, germanium, tin, lead and bismuth. Now, it is also called fourth A group. The elements belong to from carbon to bismuth. Therefore, it is called carbon family. The electronic configuration of this group is NP2. Before that NS2 will be filled. Therefore, there are 4 electrons in the outermost orbit of this group. Therefore, it belongs to fourth group. Now, which elements are present in fifth group? In fifth group we are having nitrogen, phosphorus, arsenic, antimony and bismuth. Now, it is called fifth A group. Now, it begins with nitrogen, therefore, it is called nitrogen family, and electronic configuration of this group is NP3. Before that 2 NS2 electrons will be there. Therefore, total 5 electrons in the outermost orbit. Therefore, it belongs to group 5. Which elements are present in sixth group? Now, in sixth group oxygen, sulfur, selenium, tellurium and polonium elements are present. It is also called 6th A group. It group begins with oxygen, therefore, it is called oxygen family. Electronic configuration is NP4. There are 4 p orbital electrons, 2 s orbital electrons, in total 6 electrons in the outermost orbit. Therefore, it belongs to group 6. Now, can you tell me the another name of for this oxygen family? Now, children, oxygen family is also called as chalcogens. Which elements are present in the 7th group? Now, in the 7th group we are having the elements like fluorine, chlorine, bromine, iodine and astatine. Now, it belongs to 7th A group. It begins with fluorine, therefore, it is called fluorine family, but the name for them was given as halogen family. We will see later on why this name was kept for this group. Electronic configuration is NP5. 2 s electrons are already available, therefore, there are 7 electrons in the outermost orbit of this group. Now, children, you see what is meant by the term halogen? Halos means sea salt, genus means produced. Now, children, these halogens are derived from the salts. Where we get these salts? From seas or oceans. Therefore, the term halogen was kept for them because they are obtained from sea. Now, you see elements fluorine, chlorine, bromine, iodine all are salts. They are obtained from oceans and seas. Now, which elements are present in 8th group? Now, in 8th group we have the elements like helium, neon, argon, krypton, xenon and radon. Now, it belongs to 8th A group. Now, it is also called inert gas family or noble gas groups. Electronic configuration is NP6 and 2 ns electrons are available. Therefore, the electrons in the outermost orbit are 8 electrons. Therefore, it belongs to 8 group. Now, it fits for octet rule. Therefore, they are very rigid elements. They show inertness towards chemical reactions. Therefore, they are called inert gases. They are also called noble gases. Now, why the group 18 elements in the modern periodic table are called inert gases? Now, children, these gases will satisfy the octet rule. Therefore, they will not combine with any other element and also they will not take part in any chemical reaction. Therefore, they are called rigid elements or inert gases. All these elements are gases only. The group 18 elements in the modern periodic table are called inert gases or noble gases or 0 group elements. For example, the element helium shows inertness. Atomic number is of helium is 2. The number of electrons in the outermost orbit is 2. Now, you see 1s cell. Now, here the number of electrons you see 2 electrons are available. Now, electronic configuration is 1s2. Now, here electrons are fully filled in this orbital. Therefore, no atom can combine with them. Therefore, they show inertness. Helium shows inertness because its outermost orbit is fully filled. There are only 2 electrons, it is completely filled. In s orbital we can accommodate only 2 electrons. Now, we will look at another atom here. It is the atom of neon. Here in the outermost orbit we will have in total 8 electrons. Why? Because electronic configuration of neon is 1s2, 2s2, 2p6. In the outermost orbit there are 8 electrons. The element neon shows inertness. Its atomic number is 10. Number of electrons in the outermost orbit are 8. Neon shows inertness because its outermost orbit is fully filled. Its s orbital is filled, p orbital also fully filled. P orbital can accommodate 6 electrons and s orbital can accommodate 2 electrons. Total 8 electrons are fully filled. It is satisfying the octet rule. Therefore, the elements in this group like neon, the other elements argon, krypton, xenon and radon also show this inertness because their outermost electronic configuration is fully filled. They cannot take part in the reaction. That is why these elements are called inert gases. Now, write the electronic configuration of noble gases and discuss with your friends. Group 1A family is called alkali metal family. Group 2A family is called alkali earth metal family. Group 3A family or 13th group is called as boron family. Group 14 or 4A group is called as carbon family. Group 15 or 5th A group is called as nitrogen family. Group 16 or 6A group is called as oxygen family or chalcogen family. Group 17 or 7th A group is called as halogen family. Group 18 or 8th A group is called noble gas family or inert gas family. Now, this all about the groups. Now, PPT sir, just observe the electronic configuration in the outermost shell. First group is having 1 electron, second group is having 2 electrons, third group is having 3 electrons, fourth group is having 4 electrons, fifth group is having 5 electrons, sixth group is having 6 electrons, seventh group is having 7 electrons, eighth group is having 7 electrons in their valency shell. Now, present sir. Children, we have seen that the number of valence electrons according to that only group number has kept. Now, children, please remember here that in chemical bonding chapter we will learn more about valency. Now, so far valency is nothing but its group number. Now, valency another definition is also there. The combining capacity of an atom is called valency, that we will learn in chemical bonding. Now, so far valency is nothing but number of electrons available in the outermost orbit. So, repeat once again. Now, in 8th group we are having 8 electrons. Now, next in the modern periodic table along with groups we are having periods. In the modern periodic table the horizontal rows are called periods. There are 7 periods in the table. Now, how they are arranged we will see. Now, these periods are numbered from 1 to 7. They are represented by Arabic numerals from 1 to 7. In the modern periodic table we are having 7 periods. It is the first period 2 elements hydrogen, helium, second period 8 elements, third period 8 elements, fourth period 18 elements, fifth period 18 elements, sixth period 32 elements. The sixth period also includes this lanthanide family which is down. Seventh period it can also accommodate 32 elements, but so far only 26 elements are available for us under this period. Now, it is lanthanides, these are lactinides. Now, we will discuss with periods. Now, periods are nothing but horizontal rows within the periodic table. Now, we will see how electrons are arranged here. Though the number of main shells present in the atom of particular element decides to which period it belongs to. Now, it contains the elements atomic numbers 1 and 2. In first period we are having only 2 elements, those are hydrogen and helium. It is the shortest period. It contains only 2 elements hydrogen and helium. Now, observe them. In the first period element hydrogen 1 proton, 1 neutron, it is having only one shell, K shell. Now, 1 electron is filled in that shell. The electrons of hydrogen are in K shell, this is the first shell. Now, electrons are there in which shell, that is nothing but its period number. Here electrons are having the K shell, it is the first shell, therefore, period number is 1. Therefore, the element hydrogen belongs to the period 1 with electronic configuration 1s1. Now, like this observe for helium atom now. Now, within the helium atom we are having 2 electrons in the first shell. Now, electrons of helium are in K shell, this is the first shell, therefore, it also belongs to period 1, its electronic configuration 1s2. Now, hydrogen and helium atoms contain only one main shell, that is K shell, therefore, they belongs to period 1 because K shell is the first shell or orbit. Now, what are the elements in the first period? See, hydrogen, helium, these are the 2 elements in the first period. Now, second period it contains the elements from atomic number 3 to 10, it is the short period, it contains 8 elements from lithium to neon. Now, lithium atomic number is 3, the electrons in the lithium are in K and L shell, you observe, therefore, the element lithium belongs to period 2. Now, you see in this figure first shell K shell, here electrons are filled, next shell it is entering L shell, Here also one electron is filled, electrons are entering in the second shell, therefore, they belong to period 2. It is the second period. Now, similarly, the elements beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon contain 2 main shells, that is K and L in their atoms. Therefore, they belong to period 2. Second period starts with second main shell, that is L. After K, we will get L shell. L shell has 2 sub shells, they are 2s and 2p. Within 2s we can accommodate 2 electrons, within 2p we can accommodate 6 electrons. 8 type of configurations are possible in this shell L, like 2s1, 2s2, 2p1 to 2p6. Now, within the second period we are having 2 s block elements and 6 p block elements. Now, 2 s block elements are lithium and beryllium, 6 p block elements from boron to neon. Now, observe the second period here, it starts from lithium, second period starting from lithium ending with neon. Now, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon are all belonging to the second period, because the electronic configuration is 2s2 and 2p6, all belongs to second period. Now, third period, it contains the elements from atomic number 11 to 18. This is also short period. It contains 8 elements from sodium to argon. Third period, you see how electrons are arranged here. First K shell, 2 electrons are arranged. Next L shell, electrons are arranged in the L shell, 8 electrons are filled. Now, you see they are filling with 8 electrons. After that, M shell, here 1 electron is filled. Now, sodium is the first element in this period with atomic number 11. Now, the electrons of sodium are K and Lm, therefore, the elements belonging to the third period, their electronic configuration is 3s2. Now, like this, all elements in this period enter into the third orbital or third shell, therefore, they belong to third period. Now, similarly, the elements sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon contain 2 main shells, 3 main shells K, L and M in their configuration, therefore, they belong to period 3. Now, third period contains 2 s block elements and 6 p block elements. Now, here you observe in third period there are total 8 elements from sodium to argon. All these elements electrons enter into the third orbital or shell, therefore, they are called third period elements. Now, so far we have learnt about modern periodic table, periods, groups, lanthanides and actinides. Let us have small homework in the form of improve our learning. Now, the number of periods and groups in the periodic table are called dash. The basis of modern periodic law is dash group contains number of halogen family, while lanthanides and actinides are placed separately at the bottom of the periodic table. Define the modern periodic law. Discuss the construction of the long form of the periodic table with your teacher. Now, children, so far we have discussed about the arrangement of groups and periods within the modern periodic table. Now, like this, our periodic table is also classified as S, P, D and F blocks. There are 4 F blocks in our periodic table that we will discuss in the next class. Here transition metals, gases, metals and metalloids are also included. How they are arranged in our periodic table we will see in the next session. Children, in this session so far we have discussed about the modern periodic table, how the elements are arranged in the modern periodic table in periods and groups with their increasing atomic numbers and electronic configuration. Children, in the next session we will see how our periodic table is arranged. Our periodic table is arranged in the form of 4 blocks. They are S, P, D, F blocks. These are including metals, gases, metalloids and rare earth metals. How they are arranged, where they are arranged, we will discuss in the next section. Thank you.